In number theory, the geometry of numbers studies convex bodies and integer vectors in n-dimensional space. The geometry of numbers was initiated by Hermann Minkowski. The geometry of numbers has a close relationship with other fields of mathematics, especially functional analysis and Diophantine approximation. The problem of finding rational numbers that approximate an irrational quantity. Minkowski's results. Suppose that gamma is a lattice in n-dimensional Euclidean space Rn and K is a convex centrally symmetric body. Minkowski's theorem, sometimes called Minkowski's first theorem, states that if, then K contains a non-zero vector in gamma, the successive minimum lambda K is defined to be the INF of the numbers lambda such that lambda K contains K linearly independent vectors of gamma. Minkowski's theorem on successive minima, sometimes called Minkowski's second theorem, is a strengthening of his first theorem and states that later research in the geometry of numbers. In 1930 to 1960, research on the geometry of numbers was conducted by many number theorists. In recent years, Lenstra, Bryan, and Barvinock have developed combinatorial theories that enumerate the lattice points in some convex bodies. Subspace theorem of W. M. Schmidt in the geometry of numbers. The subspace theorem was obtained by Wolfgang M. Schmidt in 1972. It states that if n is a positive integer, and L1, lane are linearly independent linear forms in n variables with algebraic coefficients, and if epsilon greater than 0 is any given real number, then the non-zero integer points x in n coordinates with lie in a finite number of proper subspaces of Qn. Influence on functional analysis. Minkowski's geometry of numbers had a profound influence on functional analysis. Minkowski proved that symmetric convex bodies induce norms in finite-dimensional vector spaces. Minkowski's theorem was generalized to topological vector spaces by Kolmogorov, whose theorem states that the symmetric convex sets that are closed and bounded generate the topology of a Banach space. Researchers continue to study generalizations to star-shaped sets and other non-convex sets. Bibliography: Matthias Beck, Sinai Robbins. Computing the continuous discretely. Integer point enumeration in polyhedra. Undergraduate texts in mathematics. Springer, 2007. Enrico Bombieri, Vala. On Siegel's lemma. Inventionis Mathematicae 73. 11-32. DOI 10.1007, BFO 1393823. Enrico Bombieri and Walter Gubler. Heights in Diophantine Geometry. Cambridge U. P. J.W. S. Castles. An Introduction to the Geometry of Numbers. Springer Classics in Mathematics. Springer Verlag 1997. John Horton Conway and N. J. A. Sloan. Sphere Packings, Lattices and Groups. Springer Verlag, NY, 3rd ed., 1998. R.J. Gardner, Geometric Tomography, Cambridge University Press, New York, 1995. 2nd edition. 2006. P.M. Gruber, Convex and Discrete Geometry, Springer Verlag, New York, 2007. P.M. Gruber, M. Wills, Handbook of Convex Geometry. Volume A. B. North Holland, Amsterdam, 1993. M. Grochel, Lovis, L. Shriver. Geometric Algorithms and Combinatorial Optimization, Springer, 1988. Hancock, Harris. Development of the Minkowski Geometry of Numbers. Macmillan. Edmund Lorca, Johannes Schossengeria, Rudolf Taschner. Geometric and Analytic Number Theory. Universitext. Springer Verlag, 1991. Calton, Nigel J. Peck. Tenney, Roberts, James W. An F-Space Sampler, London Mathematical Society Lecture Notes Series 89, Cambridge. Cambridge University Press, pp. XII plus 240, ISBN 0-521-27585-7, Mr. 0808777. C.G. Lecker-Kerker. Geometry of Numbers. Walters Nordhoff, North Holland, Wiley. 1969. Lenstra, K. Lenstra, W. Jr., Lovis. Factoring polynomials with rational coefficients. Mathematische Anleihen 261. 515-534. DOI 10.1007, BF 014574454, Mr. 0682664, HDL 1887 3810. Lovis, L. An Algorithmic Theory of Numbers, Graphs, and Convexity, CBMS NSF Regional Conference Series in Applied Mathematics 50, Siam, Philadelphia, Pennsylvania, 1986. Malishev, A.V. Geometry of Numbers, in Hazewinkel, Michiel, Encyclopedia of Mathematics, Springer, ISBN 978-1-55608-010-4. Minkowski, Hermann, Geometrie des Zahlen, Leipzig and Berlin. R.G. Kleubner, JFM 41.02390-3, Mr. 0249269. Wolfgang M. Schmidt. Diophantine Approximation. Lecture Notes in Mathematics 785. Springer, Schmidt, Wolfgang M. Diophantine Approximations and Diophantine Equations. Lecture Notes in Mathematics 1467. Springer Verlag. ISBN 3-545-4058-X. ZBL 0754 11020. Siegel, Carl Ludwig. Lectures on the Geometry of Numbers. Springer Verlag. Rolf Schneider, Convex Bodies. The Brun-Minkowski Theory, Cambridge University Press, Cambridge, 1993. Anthony C. Thompson, Minkowski Geometry, Cambridge University Press, Cambridge, 1996.